So we need to compute e to the u and what is it now? If u is a function of x. U prime e to the u, okay? And similarly, a constant, we can take it out easily, okay? The derivative of a sum will be the sum of derivative. Derivative of a difference will be the difference of derivatives. Product rule and quotient rule, okay? These are basic, so we can move on. Very good. And these are derivative of Trick's function, okay? Derivative of sine give us cosine. And so let us do it slowly. Now we need to compute the derivative of sine of a function of u, where we assume that u is a function of x. Okay? Then the general, what do we have here? Very good. Cosine u, and then multiply with u prime, okay? Cosine of u, then multiply with u prime. Okay, be careful. So, similar story. If we need to compute sine of cosine of u, derivative, do we have? Very good, the same story. So, it will be negative sine of u and then multiply with u prime. And what about tan of u derivative? Very good. Just from the general, we have almost everything. And similarly, cosine of u derivative. The same here, right? Negative. Oh no, sorry, cosecant. I mean cosecant. Hi, Daniel. So cosecant of u derivative, applying this formula, it would be negative cosecant of u and cotangent of u, and the whole things we multiply with u prime from the general. Similar story, right? Derivative of secant of u will be, what do we have here? Yes. And u prime. Very good. So we have all these. One more. Derivative of cotangent of u will be yes. Okay. Very good. You can prove these formula, derivative of cotangent, cosecant, and stuff by using function rules. Not difficult, okay? Those are formulas of the forward function. Now, the inverse function, okay? These are the formula for safe, it is absolute value. Okay. Then the similar story. Okay. Applying the chain rule, we have that derivative of cosecant inverse of u. It will be negative of 1 over absolute value of u, square root of u squared minus 1, and then multiply with u prime. Okay? Derivative of secant to the negative 1 of u will be this guy and multiply with u prime. Chain rule is everywhere. Okay? And how about derivative of secant of sine inverse of the function u? What is it now? The chain rule, right? The same story. And derivative of cosecant inverse of a function u, applying the chain rule. So the similar story we will have. And then multiply with u prime, right? You can write it this way, or imagine u prime, it is similar to u prime divided by 1, right? The product of two fractions. And the negative sign, you can think of a negative 1 multiplied with all things. And you can write it negative u prime divided by 1 minus u squared. Same thing. Okay? What else? Tangent inverse. So derivative of tangent inverse, it will be yes. Very good. So and cosecant and secant, cotangent, the similar story. Derivative inverse, yeah, of u, negative sign of 1 over 1 plus u squared, and then multiply with u prime. Okay? That is the derivative formulas for the inverse function of trigonometry. And I've told you to review the section 5 from Math 1021. They are well written in that notes, or you can start with this. These are some basic formulas. The definition, b should be the base of log function. It should be positive and not equal to 1. Then log base b of b will be 1, right? Because the definition of log function this implied y is a to the x. For any base b, log base b of 1. So we ask ourselves, which number should we put here, right? To get 1. And in our case, x here is 1, and any number b, then y should be 0. That is why natural log base b of 1 is 0. Okay. This is the definition. Oops, sorry. And for anything log base e, where e is a constant of anything, notation, we write it ln natural log of x. Okay. So we have the formula b to the log base b of x give us x. And the similar story, log base b of b to the x will be x. Or remember this power rule. Bless you. And here, the log base b of a product will be the sum of the two logs, okay? And the logs of quotient will be the difference of the logs, okay? And log of any function, base b of any function, u to r, we can take this power and write it as a in front of the log, okay? It's very nice, beautiful. But these are not true, so be careful. Log of a sum, it is not the sum of log, so be careful. These are not true, okay? They are not true. They're not equivalent. And these are two formulas. If you remember these, you can apply to all others one. For example, derivative of a to the u, where u is a function of x, a is a number. The formula will be a to the u times u prime natural log of a. Okay? That is the general case. If you remember this formula, you will definitely able to write down this derivative. E to the u derivative, applying to this formula, right? What do we have? From this formula, yeah, natural log of e, which is 1, right? Then that is why e to the u prime, it will be e to the u times u prime, okay? And e to the x is a specific case. So e to the u in this case, it becomes e to the x, right, from the above formula, times x prime times ln of e, which will be e to the x. Okay? So just remember one formula, recover everything. Okay? Another one, derivative of log base a of a function u will be u prime divided by u multiplied with a number, natural log of a. So therefore, in the special case, natural log of u from this formula, from the above formula, we have that it will be u prime divided by u times natural log of e. And we know that natural log of e is 1. Therefore, it will be u prime over u. Okay? So together we go over almost all the needed formulas. Okay? Now, do you have any question for me? Are they clear? Then we can start playing with some more example. Okay? Very good. Now, let us continue. Okay. If we are given the function f of x, which is e to the x times square root of 3 x squared plus 1. Okay. Now we need to compute derivative of this function, which will be e to the x times this derivative. Okay. Which formula should we use here? Yes, the product rule. And what do we have? Very good. Let us write it slowly. Plus, what is next? Again, please. Yeah, and specifically in our case.
Isn't it just e to the x?
And
then times the square root of x squared plus 2 prime?
this is cube root, okay?
Yeah, cube root, sorry.
Yeah, cube root or x squared plus 1 to the 1/3, okay? Who was that?
Marissa.
Okay, now just do it slowly. What is the derivative of e to the x here? Very good. And this one, we just rewrite it. Nothing new. And this guy does similar story, but which formula should we use? Louder, please. Or just say the result out loud. Okay, chain rule. This is u, where u is x squared plus 1, right? U to the 1/3, a number. Therefore, it will be yes, let us write it slowly. 1/3 minus 1. Then we will compute it later, okay? And then the derivative of very good, but let us write it this way, slowly, okay? Step by step. You're good, you're good. That is fast. And you can do it in the exams. But for now, I want to make clear for everyone, okay? Is very good. So the first term, we don't have to change anything. Let us rewrite it. And here, e to the x. Normally, we prefer writing the constant in front of the term. So let us write 1/3 here. Is that okay with you? And here, something to the 1/3 minus 1. And 1/3 minus 1 give us? Yes, negative 2/3. And here, derivative of x squared plus 1. Yes, 2x. Okay? Now, we can stop here. Okay? But we can do one more step if you want to. So the constant here, we can multiply it. It will be 2/3 e to the x. The negative power, we can push it down to the denominator, right? And we need to change the sign of this power, which will be what is it now? Yes, to the 2/3, or we can write it this way. Okay, they're the same thing. Very good. Thank you, Michael. Mommy, Carson. Okay, so do you have any question for me about this one? Oh, yeah, I forgot that. And the X here. Thank you, Yasini. Very good. Yeah, I failed the exams. So don't make that mistake here. Very good. So, is that okay now? Let us do another one. Very good. How about the function f of x, which is e to the x times cosine of 2x here? Okay. Which rules should we use? Yes, very good. And it would be? Yeah, let us do it slowly this way. Very good. Then e to the x primes give us? Yes. This guy, we just rewrite it. And plus e to the x here. And now we need to compute the derivative of cosine of 2x. What is it now?
The negative sign.
Louder, please.
Negative sign.
Okay, and what else?
Times 2.
Yeah, times 2, or the derivative of 2x. Let us write it this way. Slowly. Okay, thank you. And who was that?
Marissa.
Marisa, thank you. Thank you, Marisa, and let's see. Okay. Very good. Now, the final step. Derivative of 2x here give us 2. It means that this gives us e to the x cosine of 2x plus 2e to the x sine of 2x. Is it right? Yeah, be careful. There's a negative sign. So we can write it here because these are the product. Okay? So be careful with the negative sign. That's it.
Plus e to the x times negative 2 sine 2x.
Say it again, e to the x times.
For the second part, I did my final answer is e to the x times cosine 2x plus e to the x times negative 2 sine 2x.
Or negative multiplied here, you can write it. Here, it becomes 2 right here, right? And this number, you can put it here, it is okay? Yeah, because finally, they are the same thing. Okay, we can write it this way. Don't worry. E to the x, you can definitely write this. Okay, they're the same thing. But you see, be careful. This is the product. And multiply with a negative terms. That is why we have the negative sign right here. In math, we prefer writing number and then the function. This one, yeah, what is your question?
Sorry, why wouldn't we take out e to the x if it's like a common factor?
Oh, yeah, it is even more beautiful. Thank you so much. It is even more beautiful. In math, we also prefer writing this. Yeah, thank you. Was it Marisa? Or who was that?
That wasn't me.
Sorry?
That wasn't Marissa.
Yes, thank you.
That was me.
And Marisa, right? Or who
That
else?
was me.
Ashley.
Ashley, thank you, Ashley.
Would you accept both of those answers in the test?
I will accept both because they are the same thing, right? But you see, in order to find a solution, this final formula is more preferable. We can solve it faster, okay? But it's up to you. You can stop whenever you want. But in the future, when you explain to someone, the last formula is preferable. Okay, very good. So let us continue, right? Yeah. I think we're good with these derivative, right? Let us do implicit function, okay? Let us compute 9x cubed plus x squared y minus x y cubed equal to 6. Implicit differentiation, okay? In this, we know that y is a function y of x, okay? We would like to find y prime. Which is dy over dx. Just notation, another way to write it. So what should we do? Yes, we differentiate both sides of the equation. They should be the same. And it means that we need to differentiate 9x cubed plus x squared y minus x y cubed. It should be derivative of the right-hand side, right? Now, this is the derivative of a sum and difference. We can do it quickly right here. What do we have?
And 3 times 9x.
Yeah, very fast. 27 is the fast answer, but let us write it this way to avoid mistake, okay? And we can catch up. 9 times 3 times x squared. Very good. And next, which formula should we use?
Product rule.
It is a product, right? So be careful with this guy. Or let us do it slowly here. The derivative of this product, okay? Then the last terms. Do it slowly and carefully. The right-hand side will be? Yeah, thank you. So now, applying the product rules, the left-hand side becomes, what is it?
2x times y.
Yes, 2x times y, and
Y prime.
yeah, the product will be the sum of these two, x squared times y prime. Okay? Let us write it in the parentheses first. Okay? The next terms, it will be negative of, very good. Very good. Or x and yes. And what else? There's one more term. Y is a function of x.
Y prime.
Yeah. Y prime. Thank you. Who was that?
Carrington. I have a question.
Sure.
Why is it plus x times 2y? I thought it wouldn't it be times 3y? Or am I wrong?
Which one? The last,
Yeah, the
Yeah.
plus x times 2y times y prime. Yeah, that one.
Oh,
Why
okay.
is it 2y?
Or let us write it this way. Let us write it slowly. Y cube derivative. Do you agree?
Yes.
Yes. And the right-hand side. The right-hand side, we just rewrite it. Now, y is a function of x, right?
Yes.
And do you remember the formula u to the n derivative? And u in this case is y, right?
Oh, I get it now.
Okay, very good.
Okay, thank you.
You're welcome.
Could you keep going there?
Right here?
Yeah, it's like the stuff you were writing.
Okay.
Could you finish that, please?
This derivative gives us n, then u n to the minus 1 times u prime, right?
Yeah.
But in our case, this variable u is exactly the same as y because y is a function of x, right?
Okay.
Very good. Therefore, this guy becomes 3y prime, y squared times y prime, right? These two guys are the same.
Okay, I get it now. Thank you.
Very good. So just do it slowly. Okay, thank you for your questions. It clarifies a lot of things, right? So now it becomes a simpler issue, problems now. Do it slowly. This guy, we found it. Now, we should remove the parentheses and see what it becomes, right? Remove it first. In front of the parentheses, if it is a positive sign, then we remove the parentheses easily. Just write down everything inside the parentheses, which is 2x, y plus x squared, y prime, okay? But the next term is very dangerous because in front of that, it is a negative sign. So when you remove the parentheses, you have to change the sign of every terms inside here, okay? The first one, it was positive x prime y cubed, and x prime is 1, right? Let me just write it here. This one is 1 u cubed. Okay? So the first guy is 1 times y cubed, or 1, we don't have to write it again. Then we need to change to, what is it? Yeah. So very careful right here. And similarly, inside the parentheses, it was plus x times 3y squared y prime. We remove the parentheses, we need to change the sign of it. It becomes y squared, yes, and y prime. Okay, very good. So when you try to skip the steps, you may got a mistake right here, this position, right? You may forget about the negative sign right here. So I recommend you do it step by step. Okay. Now our target is to find the y prime. So it's appear in this term and in this term. Okay. So what should we do now? That is one way. Very good. We can move all the y prime to the other side. Or can we just move the other terms to the other side and we want y prime on the left, right? That is the normal way we do. It's okay. So we do step by step, okay? The left-hand side, we keep the terms related to y prime, which is x squared, y prime, keep it here. And this terms is, instead of writing x times 3, we can write it 3 times x, right? Y squared, y prime. The right-hand side, okay, we'll have this guy, right? And how does it become?
Negative 27x squared.
Very good. Remember, when you change the sign, change the signs. So, and what else?
Minus 2y.
Very good. Negative 2xy. And very good, plus y cubed. That's it, right? So now on the left-hand side, these two terms, are the common factor. So it means that we can factor it out, right? And how does it become?
Y prime parentheses x squared minus 3x times y squared.
Very good. And the right-hand side, right? Who was that?
Marissa.
Thank you, Marissa. Okay, now on the left-hand side, it is the product. Okay, so what should we do to get rid of this guy? Thank you, Matthew. Therefore, y prime will be the left-hand side divided by the right-hand side divided by the left-hand side's parameters. And that's it. So, do you have any question? Very good. So the implicit function is fine now, right? How about let us do one tangent line equation, okay? If we are given this equation, let me see. Okay, and we want to find an equation of the tangent line at x is equal to 0. Okay, before doing this, what should we do? We know about this. What are the related formulas we need to use?
The quotient?
Say it again, please.
The quotient rule?
Yes, the quotient formula. And what else?
The tangent line formula.
Very good. The tangent lines is the key things here, right? And an equation of tangent line would be, what is it?
Y minus y1 equal to m times x minus x1.
Very good. And what is x1, what is y1, and what is m in this case?
Isn't x1 0?
X1 is equal to 0. Very good. And what is y1?
F of 0.
Very good. And what is m in this case?
F prime of 0.
Very good. Thank you. Who was this?
Ashley.
Ashley. Thank you, Ashley. So these are things we need to compute. So let us do a step-by-step from the easy to the difficult one, okay? So let us do f of 0 first, okay? What is it? No. Substitute it into the equation right here, right?
-1.
Yes, it is 0 squared plus 4 times 0 plus 4 divided by 0 squared minus 4, which will be 4 divided by -4, and it is -1. Very good. Yeah, easy now, right? And then we need to, in general forms, we need to find the first derivative. Of this function, right? It means we need to find f prime at x. X squared plus 4x plus 4 divided by x squared minus 4. Definitely we can use the quotient rule immediately. Okay? But before doing this, if we think it is easy, we can simplify it first. But it's up to you. Okay? Should we simplify it first, or we just take the derivative immediately?
And simplify.
Okay, let us simplify it. So before doing this, let us try to simplify it. So how can we simplify it?
Would it be x squared plus x plus 4x plus 4?
X squared plus x plus square. Or let me just write down the formula we need to use. Which formula should we use here? This is something square, and 2 times something, and 2. And in general, it is x. This a. Let me write down the formula. Perfect square formula, right? We have seen this many times, okay? In our case, a is x, and b in this case is 2, right? So applying this formula, we can group it fast.
X plus 2 squared?
Very good. X plus 2 squared. That is the numerator, okay? And the denominator, we use another formula that you have seen it many times. A squared minus b squared will be a minus b times a plus b, right? In our case, a is x and b is 2. It means it becomes, right, x plus 2 squared, or we can write it x plus 2 times x plus 2, right? It is easier to see. Now, in the numerator and denominator, they both have the same terms, x plus 2, okay? So it cancels each other, and it becomes?
X plus 2 over x minus 2?
Very good. Okay, so therefore, the derivative of this guy is the same as derivative of x plus 2 divided by x minus 2. Derivative, okay? But it is a lot easier. to compute. So let me push it down here. So we can apply the quotient rule right here, right? It becomes, what is it?
X plus 2 prime times x minus 2 minus x plus 2 times x minus 2 prime.
Very good. So we write it slowly because this sign is negative sign. So we should be careful with this, okay? So derivative of x plus 2 and what is it? 1, right? Or the first term becomes x minus 2, right? And the second term's here? Yes. And x minus 2 square. We simplify it, right? We open the parentheses right here, so be careful. Be very careful right here. It is x minus 2 and what is it? Yeah, minus x minus 2. Very good. X cancel with x and 2 negative give us negative 4. Okay? From this, you can evaluate the value of f prime at 0, which will be negative 1, right? And then having all the information, you can write down the tangent line. Okay? Very good. And you have a good one. See you tomorrow.
I have a question.
Thank you. Bye-bye, everyone.
Can we bring a formula sheet tomorrow?
Yes, you can bring a formula sheet, but you should write it by yourself. Okay?
Mr. Tran, did you
Thank
see
you.
that I was there?
Sorry?
Because you marked me as absent, but I was already on when you marked me as absent on
Vikram?
attendance today. Yeah,
Okay.
thank you.
Thank you. You're welcome.
Hey,
Thank you. You have a good one.
hey, I came in late. Daniel.
Who was that?
Daniel.
Daniel. Okay. Thank you. Thank you. You too.